we can show the definitive estimates by comparing the control group, the 8 districts, and the treatment group, the 6 districts, visual ways in this graph. So in this graph, the x-axis is actually the year, and y-axis is the number of firms and business. So for these lines on the top will be in the 8 districts, the number of bank in 1930s, just before the banking crisis. And then this point will corresponding to the number of banks in the 8 districts for in the 1931 after the banking crisis. Presumably, and the other line, the other point is for the 6 districts. So this is the observed outcome of the 6 districts, the treatment groups in 1931 post-treatment. And this point is corresponding to pre-treatments for the treatment group. And think about that. Definitive actually relies on an assumption that the control group and treatment group, if without the treatment, the control group and treatment group, because they receive the common shock. The common shock in these cases is the banking crisis. So the banking crisis should hit these 2 districts uniformly. So presumably, if the 6th district without treatment, we can draw a counterfactual outcome for the 6 districts. It will have, because it will have the same trend as the 8 districts, because if presumably if we don't have a treatment, so everything will be the same for the 6 districts compared to the 8 districts. So we can draw a line. This line will have the same slope as the line for the 8 districts. It's a parallel line here. This long dashed line is actually the counterfactual changes of number of banks in 6 districts between 1930 and 1931. So this point will indicate the counterfactual outcome. So eventually, instead of relying on the comparison, direct comparisons of these 2 points, the difference between treatment and control, we're actually using the control to find out the counterfactual outcome of the treatment group. That's here. So the difference between these 2 points now is the treatment effects we estimate. That's 19, right? We actually see that in the table. So the difference in difference estimator does involve comparing the change in the number of banks in the 6 districts under the Atlantic Feds. That would be the treatment group, because they are the activists in terms of central bank's intervention, to the change in the numbers of banks in the 8 districts under the St. Louis Fed. That is, they're more pressing about central bank's intervention. So we can actually make use of this difference of the control group, the minus 33, or we can take it at the row minus 30s, the pre-treatment difference. We actually utilize the control group here, not as a direct comparison, but just as this graph shows, we use that to derive the counterfactual outcome of the 6th district. So the counterfactual outcome was that. That should be, this is the pre-treatment control group, this is post-treatment control group, right? So in the vertical line, the difference between this point and this point will be minus 33, right? So for the count, if 6 districts actually have the same time trend, then the pre-treatment difference in the 6 districts and the counterfactual outcome, if there is no policy changes, will be between these 2 points. So the difference in the vertical line should also be 33. right? This is how we can use the control group's outcome to derive the counterfactual outcomes of the treatment group. So this 33 is actually the counterfactual changes of the 6 districts. So we use the actual observed difference to minus the counterfactual difference, we can get the 19th, right? The same for another way to think about that. If we use that is we use the column, we use the marginal effects at the column. We can also derive the same outcome based on the marginal effects at we use the marginal effects at the row to derive the outcome this way. And we can also use the marginal effects at the columns to derive the same outcome. How is that? Think about that. So, and we can calculate the difference. This is the pre-treatment's outcome for the control group and the pre-treatment outcome for the treatment groups. So the difference between these two time points, these 2 points at the vertical line will be just minus 30s, will be here, right? This is a different pre-treatment. And then, because if for the counterfactual outcome, if we draw a parallel line here, and if we got the difference between the post treatments for control group and the counterfactual outcome of treatment between this point and this point at the vertical, that will be, well, if we compare the observed outcome, that will be this one, right? That's the minus 11 will be this part. And the treatment effect now is equals to, if we use this difference minus this difference, because this line, this distance should be the same as the distance between these 2 points, the counterfactual outcome and the observed outcome at the post period for the 2 groups. And then if we use this outcome to minus the observed difference, we will get the treatment effect. That will be just minus 11 minus 30s. That will be 19s again. That's the other way we can get the exact same outcome for the treatment effects. So if we write it in the equation, this is what we got. This is actually we use the marginal effects at the row to calculate the diff in diff estimator. And this is exactly why we call it diff in diff. This is the first difference and the second difference. So different and different is the estimate outcome. That's the treatment effect. So you can see, again, the different diff, this calculation actually relies on an assumption that is the parallel time trends assumption. The counterfactual outcome for the treatment group should, the growth rate of this line between the counterfactual outcome and the pre-treatment outcome should have the same slope as the line of the control group, because these 2 lines should be parallel. This is what we call the parallel time trend assumption. So in other words, it also means actually there's nothing other than the treatment in these cases other than the central bank's lending happens between these 2 groups in the treatment period. In fact, the actual Mississippi banking crisis story, it has 2 steps. So before 1930s, there was no banking panics in Mississippi, so no particular needs for policy action by the Federal Reserve. We therefore expect the policy difference between the Atlantics and St. Lewis fact not to matter. By the summers of 1930s, the St. Louis Fed have changed its policy stand and also start lending to the troubled banks. So there is no policy difference between the 6th and 8th district after the mid-1931 anymore. So the only treatment period is actually, that would be the periods that these two districts has different policies, right? That would be actually between 1931 to the mid-1931, the beginning of 1931 to the mid-1931. But after the mid-1931, because St. Louis, the control group is also kind of start to lend money to those banks in crisis. So after this period, we should also consider this is not the treatment period. The treatment actually end. But think about that, after 1931, there was also this Great Depression. So banks once closed, stay closed, and no new ones open. So before 1930s and after 1941, the number of banks should have evolved similarly in the 6th and 8th districts. Because in these two periods, there's no treatment, but only the periods in between, we have the treatment, we have the policy difference. We can use this period to track the parallel time trend assumption I just mentioned. So in the period there's no treatment, there should be parallel trend of parallel growth trends. So let's see if that's the result. So in the pre-1930, there will be this line to this line. Well, more or less parallels, right? And then post-1931, there will be this line and this line. Again, more or less parallel. Only in the treatment periods we can see a very significant seemingly difference between the slope of the line. And to the control group, it actually dropped more dramatically than the treatment group. That makes sense, right? Because the 6th district actually got the policies from the Federal Reserve of Atlantic. They got money. So kind of bail out a little bit, so save their ass. If we can also draw the counterfactual outcome based on this line, just draw the parallel line from this point onward, parallels to the line for the A district. And if we draw this parallel line, this one will reflect the counterfactual outcome of the 6th district, okay? So we can see, so here in the 1930s, so the actual treatment effects, as I said that before, should be the distance between these 2 points, right? The observed outcome and the counterfactual outcome. And you can see this, these treatment effects actually exist. These treatment effects, actually exists after the period, because it already changed the level of a number of banks in the 6th district. So this type of effect actually keep, because there's no other policy reverse the effects or strengthen the effects. So this more or less persists over time. The treatment outcomes it create. So we can also put this definitive in a regression setting. Think about that. We define 3 variables. One is the treatment variable. It's an indicator for the treatment district. Actually, there will be 1 if our data point is referring to the 6th district, and 0 if it's A district. So another variable, another dummy variable is pose. It's an indicator for the treatment period. That's 1931. So for the periods before 1931 and the periods post will both be 0. And eventually we have the DD estimator will be the interaction term between this treatment and post variable, the interaction term between these two dummy. Because in total we have 4 data points, right? So the coefficient delta here, the coefficient for the interaction term, is actually the equals to just taking the mean difference of the control group, treatment group minus the mean difference of the control group. That's the treatment's effects, right? If we run that in R, so the way we run it is pretty much the same as before. This is a dependent variable in the LM function. Where is it? Yeah, here in the LM function, dependent variable. The treatment dummy, post dummy, and the interaction term. And the data is this bank data. This is the outcome. We can see it produced no standard error, t values or p values for us because in total we have 4 data points, and we also have 4 estimates, right? So in total we have no residuals because we use up all the degrees of freedom. There's no variation on the estimator. We only have 4 time points, four data points, right? So we cannot estimate the standard error, t values, or p value. So the estimate for the alpha, the treatment group coefficient, post coefficient, and interaction term, the delta, is corresponding to the mean. So we can actually look at what this what is the conditional expectation each of the coefficient represent. So think about that. If we have a treatment equal to 1, the treatment group equal to 1, post equal to treatment equal to 0, post equal to 0, meaning that's referred to the control group pre-treatments, right? And that will be this one 0, 0, 0. So that's just alpha. So the conditional y, the effect, the expectation value of y conditional on the treatment equal to 0, post equal to 0, that will be alpha. That's just the mean of number of bank in the 90/30 for the A district. And then if your treatment is 1, post is 0, and then the interaction term will be 0. So we have alpha and betas left. That will refer to the treatment equal to 1, post equal to 0. That will be in the 90/30s for the 6 districts, right? The mean for the 6 district. The same. If we have treatment equals 0, post equal to 1, and then interaction is 0, we have alpha plus gamma. That will be the effects of the control group, the A districts in 1931. Eventually, we have the treatments in the treated period, in the post period, that will be 1, 1, and 1. That's alpha plus beta plus gamma plus delta. That will be equal to the means of y for 6 districts in 1931. Okay, this is the, so in total we have 4 conditional expectation of y dt, and all of them can be represented by 1 or the combination of the 4 coefficients. And how to prove that actually how to prove that the conditional expectation, our original DD estimate formula is the same as running a regression or simple regressions using that 3 variable treatment, post, and interaction term. Let's think about that. So we can actually plug in the conditional expectation into this formula, right? So y 60 districts 1931, that would be alpha plus beta plus gamma plus delta, right? 60 district 1930, that would be alpha plus beta. 8 in 1951, alpha plus gamma minus this one will be alpha. So we cancel out alpha and beta in the first part and cancel out alpha in the second part. We will have alpha plus delta minus gamma plus delta minus gamma. So eventually we only have delta. So it's exactly the same. And there's another way we can actually write the regression DD equation. Instead of the interaction term of the treatment variable and the post variable, we can write it as, we can define a new variable called the policy on. So the definition of policy on will be just indicates the districts and period where the policies under investigation is switched on, meaning that it's actually indicate the observation is referring to the treatment group in the treated period. Okay, so for this very simple example, at this moment, this is just a renaming for the interaction term. We rename it. It's exactly in this particular cases. It's exactly the same as the interaction term. We just renaming it as policy on. But when we kind of why we want to do that in these cases, when we trying to like consider more unit, consider more treatment group, and more period in basically adding more extending this DD regression to accommodate more data point, you will find it's actually useful to define a new variable instead of using the interaction term. I will show you in a minute quickly why. So let me ask you a question. Okay, your turn. With more than 2 periods, we cannot use DD to estimate the effects of policy if in which of the following is true, that we cannot use DD. Let us see one by one. A, the policy does not change in the treatment district during the sample period. If the policy actually doesn't change in the treatment district during the sample period, meaning that we don't actually have a PM post for the treatment group, then obviously we cannot apply the DD, right? We lack of the first part of we lack of this part of the equation of the formula, right? So A should be true. Then B, the baseline, this one should be true. Okay. Can I highlight it? Yeah, let's see if I can highlight it. No, okay. This one is true. And B, the baseline outcome in the treatment and control districts are the same. Well, meaning that the baseline outcome in the treatment and control, the YI in the treatment and control group are the same. That's okay, right? No matter whether it's the mean of the treatment group and control group, P treatments are the same or post treatment are the same, that will be fine. That's one type of outcomes, right? If there's a post period that actually indicates that our baseline outcome, that actually indicates probably the policy have no effect, and that's okay. We can still use DD. The third one, C, the policy change in the treatment and control districts, the policy change in the treatment and control district at the same time. Well, in this case, meaning that the policy also apply to the control group and also at the same time. So we will not have this different treatment, right? So again, so C is also, we cannot use the DD because there is no policy difference that we can estimate. D, the policy change in the treatment and control districts at different time. Then this is exactly the case of the banking crisis, right? So for the control group in the St. Louis district, they later on actually adopt the active lending policy. We meaning that the control group after 1931 actually become the treatment group also, but still, because in a short period of time between 1930 and 1931, we can actually have the policy difference between the treatment group and control group. So we can still apply the DD. So D is actually, we shouldn't choose D because we can use DD for in these cases. Another question, suppose the Carver's banking crisis and Atlantic versus St. Louis policy difference lasts for both 1931 and 1932, and you have data on those two periods only. Can you estimate this DD question? Yes or no? Let me make 5 seconds. 3, 4, 5. Okay. So the policy difference actually lasts for both periods. And you only have the data for this 2 period, meaning that you actually don't have pre, right? You don't have a pre-periods when the policy apply, didn't apply. You don't have the pre-period for the treatment group in these cases. So no, we cannot estimate. Think about that. So if in these cases, the treatment group we will have 1 and 0, but the poles will all be 1. This poles will be a constant, right? So its effect will be absorbed in alpha, and we cannot. And because this is constant, so this policy on variable will be exactly the same as this treatment group variable. So we cannot estimate the delta. No, the answer is no. The third question, suppose the Carver banking crisis and Atlantis versus St. Louis policy difference lasts for both 1931 and 32, the same as the last question, and you have data on those 2 years only. Can you estimate well, we said we cannot use, we already answered, we cannot use this estimate. Think about that. What kinds of variation, if we apply this to this a DD regression, what kinds of variation that we have? Again, because we said this pose will be constant, that will be 1. We won't see a switch on between 0 and 1, right? So this pose will be a constant, meaning that we don't have over time variation. So B is definitely wrong, right? And also we didn't use different diff variation because we lack of one part of variation. So B and C is not the answer. But between A and D is no variation at all. A is that we have a cross-sectional variation. In fact, we do have cross-sectional variation because the treatment, this is still, we have variation on this variable. So we can define the treatment and control group here. So the answer is A. We actually still have cross-sectional variation. We only lack of the over time variation. That is why we don't have the different diff variation. So why we want to extend the very simple DD formula using the mean difference to a regression setting. Well, because regression is actually very useful computation device to get the DD coefficient. And by doing so, the advantage is that it also provides EC standard error. In the example we just showed, we don't have a standard error because we only have 4 time points, right? But later on, when we expand the data point that we have in both the time and the cross-sectional dimension, then we can actually have a standard error. Then we, for which we can build our hypothesis testing on. More importantly, is the regression setup actually allows us to extend the basic DD idea. First, we can use more data, like the entire 1929 to 1934 period for the Mississippi Bank closure data. If for the mean setting, actually, we don't need so many data. It's hard to accommodate. But in the regression, we just fold all the data on in. And in the 1929 period, so the treatment and the treatment variable will be the same, and the post variable will be always zeros, right? The same for after 1931. And also we can use more than one treatment group. And we will talk more about this in the next lecture, but just remember me, just trust me for now. It has advantage in the sense that it can accommodate more than one treatment group. And also, and third, it can accommodate treatment which are not binary. Now we actually have the treatment on or off. So the treatment is actually a binary variable. That's why we can compare the mean difference between those have and have not. How about if our treatment, for example, in the banking crisis example, suppose we didn't compare the district 6 and district 8. Suppose we have another district, maybe district N, and for the district N, it also adopts active policy, lending policy. It only compares to the lending. It didn't make that much effort. For example, if the Atlantic's Fed actually increased their lending to banks by maybe 40%, so this district N, it actually increased only by 20%. So it means they do have a treatment. They didn't make that much effort. And actually we can still, now we can change the question into, okay, it's not 1 or 0 question. It's actually whether you make 40% of a lending increase or 20% of lending increase, how much this treatment difference actually make on the outcome. So in the regression framework, we can easily extend, so that we can, for the treatment variable, we can change that into maybe the difference of the change of lending rate instead of just a dummy variable as the key regressor. Eventually, remember we said that the DD estimate actually relies on a common trend assumption. But in the regression framework, we can actually relax this common trend assumption by adding more control. We also will talk more about this in next lecture. So in the next lecture, actually not lecture, in the next section, I will show you why this regression framework is so nice. It gives us so much flexibility to accommodate all this variation, to extend our basic framework of DD. So let's look at, okay, for these cases, let's look at maybe more time period. So the first advantage, right? Now, suppose we, other than 1930s and 1931's data, for the two districts, we have the data in between 1929 and 1934, because now we have more degrees of freedoms than a number of estimate coefficient. We can actually calculate the standard error and then have the t-test, right? So variable is the same as before. The Y variable treatment group pose dummy and then interaction, or the switch on variable. And let's just look at the result. The result is actually for the treatment group, the policy effect is lead to, the policy actually have the effects leading to 40s numbers of banks more for the treatment groups post the treatment, and it's actually significant because we have a really significantly sizable t-value. And remember we said sometimes you can actually take the log of the dependent variable in these cases, because the key regressor now is a dummy variable. For dummy, you don't take log, right? But you can take log on the Y variable because it's a continuous variable. After taking log, the dependent variable will be interpreted as marginal changes. So, meaning that if we take log of the Y variable, this is the outcome that we have. We still have a significant outcome, but now the estimate is 0.08, about 0.08. That means that 8%, this coefficient, if we interpret it, it should be actually for the treatment group, the policy effect is 8% increase of the number of bank. And for the level variable, if we directly use the number of banks as a dependent variable, we already checked the graph. It fulfills the parallel trend assumption. How about in the log variable? Does it also fulfill the parallel time trend assumption? Let's look at that. Let's look at that in the graph. So we take now the dependent variable, the y-axis, it's a log number of bank in business. So this is a pre-treatment period, post-treatment period, and the treatment period. You can see even after taking log, it's more or less parallels, right? The growth rate is more or less parallel in the pre-treatment period and also post-treatment period. Only difference in the treatment period. So it means even after taking log of the dependent variable, you still have the parallel time trend assumption fulfilled. So far, we look at the outcomes. We look at the policies, the central bank policies, effects on the bank industry. You can extend this analysis on the real economies as well, because eventually we care about the real economy. So we use the number of wholesale firm and the net wholesale sales quantity as a two measure on the outcomes of the real economy. And we look at the data in the 1929 pre-treatment and 1933 post-treatment. So this is for the treatment group and the difference, and the control group and the difference. And then we take the difference at the margin. This is the outcome we have. So the different estimate actually give us the number of wholesale firm is 181 more in the treatment group if the district actually receive, if the district's bank actually receive lending from the Federal Reserve. Same for using the net wholesale quantity as a measure, right? So for the treatment groups, that's 81 million more wholesale sales. It means that this outcome actually indicates, well, by lending monies to the bank, it also helped the real economy to kind of enduring this crisis. That is why so this experiment and this paper in 2000, I think this paper studied the Mississippi banking crisis, actually published in 2008 or 2009. So now, more or less, we have a consensus during the financial crisis, the central bank should act actively to kind of save the economy, not only the financial industry or the banking industry, but also it will have huge effects on the real economy. That actually happens in 2008 and most likely happen today. You can see in the US, Donald Trump already issued a huge, I think a $2 trillion saving plan to trying to save the economy. Of course, his plan is not just by the central bank. It actually extends to the whole federal government. The same for what happens today in Hong Kong, because it's a necessary step. So to sum up, definitive estimate, we can use that to analyze policy changes. It's a very good tool to study policy changes. By using the definitive estimate, the advantage compared to the experiment setting that we rely on randomization, now we don't need the treatment group and control group to be balanced in level before the treatment. Okay, they don't need to have the same mean for outcome before the treatment. Now we relax this assumption a little bit. We only require they have a similar time trend or growth over time. That is, in other words, it sort of assume that other than the treatment we observe, there should be no other treatment or shock specific to either the control or the treatment group. And we can actually look at the period before and after treatment to track the parallel time trend assumption. The best way to check this assumption is by graphing the data and check it visually. And also, the regression is a convenience tool to compute a different estimate. Using the regression framework to replace just taking the formula, just to take the mean difference, has a lot of advantage, and we will see those advantage in the next section.